Good morning all. Now in today's session we are going to consider about voltage to current converter and current to voltage converter. So basically if you go for the introduction to the signal converters, then we can say the signals can be analog or digital by nature. Sometimes we need to convert analog signals into their digital equivalent and vice versa. The electronic circuits used for such a conversion are called as data converters. Due to the advantages offered by the digital systems, they are widely used in many fields such as instrumentation, computers, communication, and control. In many such applications, the signals are not available in the digital form. Most of the physical quantities such as temperature, pressure, displacement, vibrations, etc. are available in analog form. These quantities are represented accurately in analog form, but it is difficult to process, store, or transmit the analog signal because error gets introduced easily due to noise. Hence, to reduce these errors, it is always better to express these physical quantities in digital form. The digital representation of signal makes storage possible, processing simpler, and transmission easier. Therefore, A to D conversion is necessary. Now, once the processing transmission is done by the signal, it should be brought back to its analog form, for which D to A conversion is essential. In addition to the data converters, we will discuss two other types of signal converters that we can call as voltage to frequency converters or frequency to voltage converters. The voltage to frequency converters are also known as VCO, that is we can call it as voltage control oscillator. The circuit which produces an output current proportional to its input that input should be input voltage, that is called as V to I converter. I repeat again, the circuit which produces an output current which is proportional to its input voltage is called as V to I converter. The voltage to current converters can be classified in two categories depending on the position of the load, that is V to I converter with floating load and V to I converter with grounded load. Now first we can consider V to I converter with the floating load. Here the circuit diagram shows a voltage to current converter with a floating load. This load RL, if you observe here, this load RL that we can call as floating load because it is not connected to ground. The input voltage is applied to non-inverting terminal, that is input terminal of the operational amplifier. Load resistance RL is connected in place of the feedback resistor RF. That is, in conventional non-inverting amplifier we are going to be connected in the same way, and this circuit is called as current series negative feedback amplifier. So this is because the feedback voltage across R1 is proportional to the output current I0, we have this current, and appears in the series with the input voltage. So if you apply the Kirchhoff's voltage law to the input loop, then we can write Vin is equal to Vd plus Vf. So we know that open loop gain of the op-amp is very large, so we can say Vid equal to 0. So we can write Vin is equal to Vf, but Vin is equal to, we know that it is R1 into I0. So as Ib is equal to 0, so we can write I0 is equal to Vn upon R1. So the input voltage Vin is converted into a proportional output current I0. So that is equal to Vin by R1. So if R1 is a precision resistor, then we can precisely adjust the output current. So some of the typical applications of voltage to current converter are, we can say it is voltage DC and AC voltmeters, LED and Zener diode testers, etc. Now we will go for V2I converter with inverting amplifier. The V2I converter with input applied to the inverting terminal is shown in this particular figure. The type of load is still we can consider as a floating type. So the point B in the figure itself here, it is a virtual ground and the current flowing into the inverting terminal we can say it is 0. Therefore we can write In is equal to I0, but we know that In is equal to Vin by R1 as point B is at virtual ground potential. So we can write I0 is equal to Vin by R1. Thus, the current flowing through the load is proportional to the input voltage Vin. Hence, this circuit is also a voltage to current converter. The disadvantage of this circuit is that the entire load current has to be supplied by the input source itself. And the applications of this V2I converter we can consider as diode match filter, then LED driver or tester, Zener diode testing, DC voltmeter as a relay driver also. Now we will see the V2I converter with grounded load. This is a other type of V2I converter in which one terminal of the load is connected to ground. The V2I converter with ground load is shown in this particular figure. If you go for the analysis of the circuit, then that can be divided in two different steps. In first step, we have to determine the voltage V1, that is at the non-inverting input terminal, and the second step is to obtain the relationship between V1 and the load current IL. So if you apply the Kirchhoff's current law at the node V1, then we can write IL is equal to I1 plus I2. So we know that I1 is equal to Vn minus V1 upon R, and I2 is equal to V0 minus V1 upon R. So we can put this value, so we will get IL is equal to Vn minus V1 upon R plus V0 minus V1 upon R. Therefore we can write IL into R is equal to Vn plus VO minus 2V1. So we can rearrange the terms and we can write V1 is equal to Vn plus VO minus IL into R by 2. Thus we have obtained the expression for V1. So if you consider in terms of gain, so we can write AVF equal to 1 plus R by R is equal to 2. So we can write it as VO is equal to twice of V1. So we can rearrange the terms and we will get it in terms of IL is equal to Vn by R. So this equation shows that the load current is dependent on the input voltage and resistance R. So this is about the V2I converter with the grounded load. As I already told that what is meaning of the V2I converter. It is a circuit which produces an output current which is proportional to its input voltage, is called as V2I converter. The voltage to current converters, it can be classified in two categories depending on the position of the load, that we have seen in the V2I converter with floating load and V2I converter with the grounded load.